Hello and welcome to the first lecture of this new section on root cause analysis in this course AI for Problem Solving Excellence. So in this section, we will help you use AI for excellence in root cause analysis because that's a part of problem solving, isn't it? And we will begin by taking in this lecture, how can you use machine learning models to correlate inputs, which are the variables, for undesirable outcomes, independent variables, inputs with dependent variables and undesired outcomes. So, so how do you think you can use, machine learning models to correlate inputs with undesired outcomes? Any thoughts? Now, let's take a look at the step-by-step approach for using machine learning to find which inputs are most strongly associated with undesirable outcomes. Undesirable outcomes like churn, product defects, delays, fraud, etc., etc. And your output could be different, but something which is undesirable, right? So first step obviously is to define the problem and outcome variable. So you need to be precise about what is undesired, understand what you want to predict and explain, and examples of this would be like churn, customer stops using the service; defect, the product quality is falling short of the expectation or fails in quality checks; the delays, which means basically shipment misses the delivery dates for the customer orders; and frauds, where there is suspicious transaction. And your target variable in ML terms should be binary, uh, 1 or 0. 1 is undesired, 0 is desired, or numeric in terms of defects count. So like this, you define the problem and the outcome variables. Then you collect and prepare data. You figure out input variables, features like operational matrices, customer behavior, demographic info, environmental factors, etc., and outcome variables, outcome labels, like historical data indicating whether the bad outcome occurred. So that's the input and output data collection and preparation. Then you clean the data. You remove duplicates, handle missing values, and ensure consistent format. Then you do feature engineering in which you create additional variables that may be relevant. For example, time since last purchase, defect rate per shift, etc. And please remember to normalize or standardize features for certain models like logistic regression and SV. So collect and prepare data accordingly. Then you choose the right machine learning model. If you want to use a supervised model, which is the most likely case because you have historical labels, you will then look at the various models that are, what are the common models in supervised learning. So the common models are like models for variable, common models for variable correlation analysis are like logistic regression, which are interpretable, gives direct correlation coefficient. Then there are decision trees which show rules that lead to bad outcome. Then there is random forest gradient boosting like XGBoost and Light GPM, which handle non-linear relationship well and can rank variable importance. And there is SHAP, shapely additive explanations, which are model agnostic methods to explain future contributions. So like this, you choose the right machine learning approach. Then you train the model, obviously, right? So examples are using machine learning models like logistic regression for interpretability. You import pandas as PD and then you give the commands that you see here. Then you load the data using the command that you see here. Then you define features X and target variable Y. Then you split the data in training, testing, right? And test size and random state. And then you scale. You scale the data using scalar. Then you train the data. Then you determine the feature importance. And finally, you print the importance of the model that you have trained, right? So that's an example of using logistic regression for training for interpretability. Then you interpret variable influence. There is logistic regression which has positive, which mean where the positive coefficients means increasing the risk of bad outcome. Negative means reduces the risk of bad outcome. Then there are tree-based models, where you use feature importance or sharp values to see which features have the largest impact. And then you have sharp plots where you exactly see how each variable pushes prediction towards the undesirable or desired outcome. Let's take a look at some example of outputs. Now, if your features are like you see three features here: days since last login, complaint count, on-time shipment percentages, and then you've seen the odds ratio in terms of the impact. And the interpretation is that since days since last login has very high impact in terms of 3.5, high activity triples churn risk, right? Odds ratio. So one improvement in activity level triples the churn risk. A complaints count has frequent complaints, doubles the detection risk, and on-time shipment rate, high punctuality reduces the delays. So that's the interpretation of variable influence, right? Then you validate and refine the results. So use matrices like AUC, with precision and recall to ensure that the model is reliable. You work with domain experts to check if the correlation makes business sense. That's how you avoid spurious correlation. And then you retrain periodically, to adapt to the changing conditions. So that's how you validate and refine your model. Then you act on the insights. You've got insights and time to act. You focus on high impact controllable variables, right? Design interventions targeting the top drivers of the bad outcomes and monitor whether the fixing those drivers improves the future results, right? So that's how you act on the insights. Let's take a look at a real world example of using machine learning models to correlate input variables with undesired outcomes. So it's a telecom company that use gradient boosting plus SHAP to analyze the churn of its customers. The top correlations with churn were days since last usage, strong positive correlation; unresolved tickets, very high churn likelihood; and billing errors in last 3 months had medium impact. And by targeting these areas with proactive engagement, churn dropped by 17% in 6 months. So that's a real life world example of using these machine learning models. So what do we do next? We will take a look at the second lecture of root cause analysis as we go forward in the next lecture, in which we will talk about causal inference engines like do, why, and cause next, and to simulate what if scenarios. And how do you do that? That's what we will talk about in the next lecture. So thank you so much for watching this first root cause analysis lecture. I hope you continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your questions. And do download the PDF file to take a look at anything that you need to.